Wow. Those are 1, 3, and 4. Sorry. So we'll do those 3, and then I'll show you how to do those in Desmos, and then moving forward, you can be using Desmos, writing that as checked or did in Desmos. So I'll show you algebraically first. Number 1, write the equation that goes through the given point and slope. We are using ry, okay, minus y1 equals m times x minus x1. So our point slope. And then we have our y1 and x1 and our m. So we would put each of those in. Y minus 8 equals our slope 2/3 times x. You can put plus 18 or minus and then change it to a plus. Distribute and then solve for y. And then add 8 plus y equals 2/3 x plus 20. Questions on that one? For number 3, solve for y. You are trying to get y by itself. So solving the equation so that y is by itself, get rid of 2x. So that we have y equals 2x plus 5. That's it. So if it says solve for the y-intercept, you could either do this and then state what the y-intercept is, or put 0 in for x and then solve for the y-intercept. But if it doesn't say solve for the y-intercept, you shouldn't be getting the y-intercept and writing it as an ordered pair. Questions for that one? And then number 4, we have a fraction that equals another fraction. What's our first step? Cross multiply. So 6 times x plus 1, 18 times x minus 5. Or you could go straight into 6x plus 6 equals 18x minus 90. And then start to solve, move one of your variable terms to the other side and one of your constant terms to the other side. I'm going to move 6x and add 90. So we have 96 equals 12x. And if we divide both sides by 12, what is x? 8. So that is all the work algebraically. If you didn't catch any of that and want to write it in Desmos as we are about to do, as I'm about to show you these 3 in Desmos, you can also do that.
I just had a question. For number 5, do we have to draw the line?
Yes. Okay, so for number 1, you would, anytime you see something where it says write the equation that goes through the given point and slope, write in y equals mx plus b. And then you're going to type in all the sliders, or add in all the sliders. You know the slope is 2/3, you can change that. We don't know what b is yet. You can put in the ordered pair, negative 18, 8. And then we have to make sure our y-intercept goes through that point. If I just hit play here, the max it's going to go to is 10, and it won't ever cross that because our y-intercept is more than that. So we have to manually change it. So we could try it at 10, not 710. Okay. And we see that it's close, but it doesn't go through that. Then it becomes a guessing game. Start to change the numbers. 15 is close, but still not there. 18 is closer, but still not there. But at 20, it goes through the point exactly. And you would use your slope and y-intercept and write that as a y equals mx plus b for y. did the work in Desmos, would be your work. Questions on that one? Number 3, if I type in the equation that was given, negative 2x plus y equals 5, I could, because we're solving for y and we're looking for is going to end up in our y equals mx plus b format, I can look at what is my y-intercept, find what my slope is. So this would be 2x plus 5, and if I were to graph that, they should overlap. And that would be what you would do, and then you would write the equation and did work in Desmos, or found in Desmos. For number 4, you could type all of this in at the same time. It's going to look weird as I start to type it in. 6 divided by x minus 1. But the shape should look familiar because it's making that hyperbola, it's making that inverse. So when you put everything in, you can see where it goes to the x-axis at 8. And you would write x equals 8, did work in decimals. Questions on any of those? Alright, today we are starting the next portion of our notes. This is part of 6.2, but not all of 6.2, because the other way we solve algebraically will also be part of 6.2. But today we're talking about how to solve equations algebraically using the substitution method. You may have seen / done this before. I'm going to write this in. To solve by substitution, this is a method of solving systems of equations by substituting equations within one another. So you first solve one equation for x or y, does not matter. Then substitute the expression into the other equation and solve for the variable. Then substitute your answer into the revised equation or the one you solved before, and solve for the other variable. So it's a lot of solve, substitute, solve, substitute, solve. And then we're going to do at least 5 of these problems, and then any you guys want to see, and then you'll have time to practice. So start with number 1. So first step, solve one of the equations for x or y. In this case, they are both already solved for y, so we don't have to do that part. Step 2, substitute this expression into the other equation. It doesn't matter for this one because they're both solved for y. We can either substitute this expression into this y, or substitute this expression into this one. You don't need to draw that, you can if you want. It does not matter, because regardless of however you do it, it's going to look like 4x minus 1 equals 2x minus 5, or vice versa. It's going to look like one or the other. What was your question?
So substitute means just put them in this form.
You're replacing it. So instead of y here, I put this. I'm replacing it. And now that we've substituted, now we can solve for our variable x. How would we do that?
And 1.
We can add 1 and subtract 2x. So we have 2x equals negative 4. Divide both sides by 2. Now that's just half of it. We found x, we still have to find y. Remember, all of your systems, if you have an x, you also have a y, that's your ordered pair to give you one solution. So then you're going to take this x value and put it into one of these equations that's already solved for y. It does not matter which one. Pick whichever one you want. Let's say I did the second one. Now I'm substituting this value in for x instead of the expression, and then I'm simplifying. And once you have found your y, you can put those together as an ordered pair, -2, -9. That means those two, if I were to graph them, that's where they would cross. So all of your check methods from before, putting the numbers back in to both equations, making sure they work, graphing the two on Desmos or on the calculator, those still work, but you still have to do the work algebraically.
So if we were to put the -2
With the 4, would it be the same?
It should be. So here we have -8 minus 1, which was so yes. So as long as you do your math right, it doesn't matter which equation you choose. Other questions so far? For step 2, we have one equation that's solved for y and one equation does not. You don't have to solve that one. You can. You can do all of these just like this one. But some of them you don't need to. That creates extra steps if you do it that way. So because I have an equation that's solved for y already, don't have to do that part, I'm going to take this expression and in the other equation, substitute where y is. So when I rewrite it, it would be 2x plus 3 parentheses 6x equals -20. When you substitute one equation or expression into another, you should only have one variable left. If you still have two, you substitute it into the wrong thing. Let's solve that one really quickly and then we will break for lunch. So that would become 18x combined like terms. Divide both sides by 20. What is the value of x? -1, so yes. Take that value, put it back into either equation, it doesn't matter, but the easier one would be the shorter one. So y equals 6 times -1. So y is what value?
-6.
And how would we write our solution?
-1 from -6.
Questions so far?
When we write our answer, should we just write it as that?
You just write it as a order. Alright, when we come back to we move on to 3.
What would you say?
Did you have any questions about number 3 is really much the same. There's just a little bit more to it. So we already have the equation that's solved for y. So we're going to take that expression, and and put it into y of the other equation. So we have 3x plus 8 in parentheses x plus 9 equals negative 5. Besides making sure you're substituting it into the right variable, you also have to make sure you're substituting it into the right equation. If you substituted this equation back into itself, you would just get no solution or infinitely many solutions by accident. So make sure you're substituting it into the other one. Solve this. So distribute. Combine like terms and then solve. How would we keep solving this?
Subtract 72.
We have 11x minus 7 equals negative 77. And divide both sides by 11.
Negative 7.
Okay. So now that we found x, we can go back and find y. Put this value back into this equation. So y equals negative 7 plus 9, which would give us
2.
So our solution would be
Negative 72.
negative 7. Question on that? 4 is just like 3, but now it's solved for x. That's fine. It doesn't matter if it's solved for x or y, you're doing the same thing. But if this equation is already solved for x, instead of substituting it into y, we substitute it into x. So when we rewrite it, it would be 2 parentheses 4y plus 7 minus 6y equals 12. And then you could solve that one. Distribute. Combine like terms. Get rid of 14 by subtracting. And then divide both sides by 2. Then just like number 3, yes.
What happens if it's like you have to solve both on the top and bottom?
So like the ones on the back. We will get to one of those in a second. Take this, put it back into the equation, 4x. And simplify. Figure out what x is. Even though you solve for y first, you're still putting it as an ordered pair x, y, so it will still be 3, negative 1, not the other way around. Questions so far? Right, so in all the examples we have done so far, there's been an equation where a variable was already solved. In number 5, that is not the case. And this kind of answers your question, Jackson. So if you get 2 equations where neither of them are solved for the variable, you have to solve one of them for x or y. It does not matter which equation, which variable. But to make your lives easier, if you look for the equation where there is a variable either by itself or it has a negative, use that one. Any other equation or solving for any other variable may end up with fractions, which is fine, but then you have to be careful with substituting and multiplying. So if you solve this one for this y, how would I get this y by itself?
Subtracting 2x.
So we have y equals negative 2x minus 2. Now we have an equation that's solved for y. Now everything else is the same. Take this expression, put it into y for the other equation, not the same one you just solved. rewrite this so we have 5x plus 3 times in parentheses negative 2x minus 2 equals negative 8. And 5x minus 6x minus 6 equals negative 8. Combine our like terms. Get rid of 6. Divide both sides by a negative 1 to get your x value. Then after you find x, you have a couple of options. You can put this into the one you solved, or either of the two originals. It doesn't matter. You should get the same answer regardless. But the easiest one would be this one, the one that you solved. So that y would be negative 6, and our solution would be 2, negative 6. So you could easily mess something up here with solving, putting things in, forgetting a negative, adding or subtracting the wrong thing. So this would be a great time to check yourself. Take these numbers, put it back into the original. Does it work for both? If it does, you did it right. If it doesn't, go back and look at your work. Somewhere in there you may have made a mistake. Yes.
Where do we get 2 again?
This 2? Yeah. By dividing negative 2 by negative 1. Other questions? Look at number 6 through 11. Are there any of those we want to see you go over and have questions about? 10. 8. I'm trying to think of which ones are the special case, but I can't remember off the top of my head. 7 and 9. So let's change one of those. Let's do 10, but instead of 8, Ella choose, since that was yours, 7 or 9. 7. Okay. Yes. Alright, so with number 7, same process. Which variable do you think would be the easiest to solve for? The x and the first one, so let's solve for that. How will we get x by itself?
Minus 1.
Subtract by y on both sides, so we have x equals negative 5y plus 4. And then we can take that, put it into the other one where x is. So we have 3 parentheses, negative 5y plus 4 equals, sorry, I skipped, plus 15y equals negative 1. As we start to solve, you'll notice real soon whether it's a no solution or infinitely many solutions. What happens when we combine our like terms? We get 0.
0 to 4, but it's actually 12.
So here, if we combine our like terms and then whatever's left, does 4 equal negative 1?
No.
No, so what type of solution would that be?
No solution.
So that's going back to how we were solving and getting solutions. Max, you don't need to check your phone right now. Same thing, if your variables canceled, you had the same numbers, 4 equals 4, then it would be infinitely many solutions. Yeah, it should be 12. That's what you were saying, yes. No, this one. But it is still no solution. do, it's infinitely many. If you get no solution, that means you shouldn't have an x and a y value. If you have an x and a y value, it can't be no solution or infinitely many. So it's one or the other. Alright, number 10. Which variable are we going to solve for? X and the first one. Actually, let's do a different one where we solve for negative 1. 11. Yeah, it's all 1. Okay, so let's do 11 instead.
Solve for y.
So let's solve for y. How would we get that y by itself?
Subtracting 3x.
Divided by negative 1. Negative y equals negative 3x minus 8. Divide everything by negative 1. Then take that equation and do what with it?
Substitute it for the other y.
Put it in the other equation where y is. So 5x plus 2 times 3x plus 8 equals 5. And then start to solve. 5x plus 6x plus 16 equals 5. Combine like terms to get 11. Get rid of 16. So that x is what? And then go back and find y. Do you guys know how to do that? Can you tell me what you get? Do we have any questions on how we solve systems by substitution?
I would like to see if we can do 10 because it's 38, y equals 0, and that means y either is 0 or it's a no solution or something. I'm just wondering.
You would keep solving. Just divide it. But
So 0. So 0, yeah.
you can have 0 as an x or a y. 0 can be an answer. It's not no solution.
Thank you.
So then for the rest of the class, you can either do the remaining problems on this, or work on the Delta math that is due on Friday on this, solving systems by substitution. If you didn't finish the solving systems by graphing Delta math from the other day, you can work on that. So you have plenty of things to be working on. You work together, use the iPads, use Desmos to check yourself, use the calculators. While you guys are working, I'll be calling you up one at a time to talk about course